It's your friendly math tutor, Miss C here, and today we are continuing to learn about logarithms, specifically the power property of logs. So this is one of my favorite properties because I find it really useful. So let's jump in and have a look at what happens. I've got three examples, and what you're going to notice is all three examples have our base of our exponent within a log. So this property helps us deal with the exponent. So here's how the property works. So in our first example, I have the log of x to the power of 4. And having x to the power of 4 within a log is complicated. So I don't really want that. So what the power property says is we can take the exponent that's on what's inside of the log and we can kick it out in front. So we could rewrite this as 4 log of x. Just as a reminder, there's no base written here, so this logarithm is in base 10. So pretty helpful that we now separated the base from the exponent. Okay, let's move on. We have log base 6 of 36 to the power of x. This x is trapped within our logarithm until we kick it out front with this property, and that gives us x times the log of base 6 of 36. But wait, this base 6 of 36, really, this log base 6 of 36 is basically asking us 6 to what power makes 36? Well, if you said 6 to the power of 2 makes 36, you are absolutely right. So I can replace log base 6 of 36 with 2 because this is equal to this. Okay, so what is awesome about that is look how my logarithm just simplified. If I were going to write this as a final answer, we always usually write the coefficient first and the variable second. I completely was able, using this property, to get rid of my logarithm, and I'm down to 2x. So you could imagine if you were solving an equation, that'd be super helpful. They all don't work out that way, though. So let's look at another one. In this case, I have two variables. I have log base 2 of a to the power of z. It is super helpful when you have two variables not to have them attached. So I'm going to go ahead and use my power property of logs, and I'm going to kick this z to the front. So I have z times log base 2 of a, and that is as simplified as you can get. Now, some of you have wondered why I cross my z's when I write them, and you might notice that my z looks a lot like my 2 if I don't put a line through it. And having done math for a long time, that has caused me a lot of time and a lot of error. So I always cross my z's, or my z's, with a line to make them distinguishable from a 2. All right. Now, what happens if we want to go the other way? I find that sometimes we want to do this and sometimes we don't. It's really up to you. But for instance, if we had a need to do that, I want you to be able to know how. So in this case, this 5 is being multiplied by the log of 12. I could kick it back and make it an exponent. So I could say log of 12 to the power of 5. And then I could expand 12 to the power of 5 out and take the log of that. Okay. On this one, I have half log base 4 of 100. Here's why this can be useful at times. Okay, ready? Log base 4 of 100 multiplied by half, I can go here and say log base 4 of 100 to the half power. Now, you might remember from when you did rational exponents that the half power is the same thing as the square root. So I know that the square root of 100 is 10. So I could really write this as log base 4 of 10. So that makes my value within the log a little bit smaller to deal with. Okay. All right. And then I have in my next example a -3. You can do this with negatives too. So I'm going to go ahead and here I'm going to apply my power of -3, but there's a catch. This is applying to the entire fraction, not just to the 2. So to make sure that everybody knows that, and I remember that if I'm solving a long problem, I'm going to go ahead and put parentheses around this and raise the whole thing to the -3. That's a very correct answer. If your teacher is asking you for only positive exponents, you could apply the rule of exponents, negative exponents, and you could do that. And then you have a positive exponent. I have a video on that if you're wondering how that works. Either one of these answers is technically correct. And There you go. That is how you apply the power property of exponents. Once again, if this was helpful to you in any way, please like this video and subscribe. Thanks for watching, and remember, you've got this.